She's uh, is expert in working with MATLAB tools and also possesses core skill in HTML, CSS, and JavaScript for web page designing, and his passion to involve in research activities like in to contribute the modern technologies to the society. Her research interests are in fields of computer vision and artificial intelligence as well as emerging technologies and to contribute social responsible AI for his modern world. He has background in image processing and machine learning algorithms, and she worked as an assistant professor since 2017 onwards. And she involved in supervision of BTech projects and published more than 13 research papers in most reputed journals like Springer and Scopus. And she is a co-author and contributed a chapter for a book called Bio-Inspired Computing for Image and Video Processing, published by CRC Press and Taylor and Francis Group. She is appreciated for his contribution as the valuable reviewer of the international conferences conducted by NIT Agartala and NIT Trichy. So, thank you for accepting our invitation to as a chief guest for this 1 week FDP, madam. Thank you, and the session is over to you, madam.
Thank you, sir.
Thank you, ma'am.
Am I audible, sir?
Yes, madam. You are audible only. You can continue, madam. You can share your screen also.
Yeah. Yes. What about, sir? My screen is visible, no?
Yes, madam. You can start your session. Your screen is visible and your voice is also good, madam.
Thank you, sir. Thank you for your brief introduction. Good evening, all. Let us move on to the session data science using R programming. This is not the complete hands-on session, like it is a semi-hands-on. Like I will give you the R commands while delivering the content. First, let us see what is data science. So as we all know, data science, it is an interdisciplinary field. It is something logic and statistics. We also can say data sciences, it is the process of transforming hypotheses. So hypotheses are nothing but the assumptions regarding a population parameter, and data, it is an information into actionable predictions. So data science is nothing but it is transforming hypothesis or data into actionable predictions. So predictions like who will win an election, or what products will sell well together, or which loans will default, which advertisements will be clicked. And these are some of the flavors of data science. First one is Amazon product recommendation system. So all these recommendation system, valuable systems are using data science, right? So in Amazon recommendation system, they are using the technologies like artificial intelligence algorithms and machine learning to improve the customer experience and to increase the sales. And others like Google advertisement valuation system, then LinkedIn contact recommendation system, then Twitter's trending topics and Walmart consumer demand projection system. So everywhere this data science is involved. And if you want to deliver a successful data science project, it is important to know the common tasks, then the steps and the tools that will be useful to use successfully to deliver such projects. And then we will see the roles in a data science project. So roles are nothing but the people who will be involving to do the data science project. Roles like project sponsor, client, data scientist, data architect, and operations. Here, when you see some of the roles in a data science project may overlap. So roles like client, data architecture, and operations will be filled by the people who are not on the data science project team, but they are the key collaborators. First one is project sponsor. Let us see the responsibilities of these roles individually. The first person who will involve is the project sponsor. He is the most important person. And he is the person who won't actually the data science result. Generally, it represents the business interest. So he is the one who is responsible to decide whether the project is a success or a failure. So he actually wants the data science result. And the second role is client. When you see the project sponsor, it represents the business interest, whereas client represents the end user interest. So he is the one will act as the interface between the technical details to build a good model and the day-to-day work process into which the model which has to be deployed. And when you see here, project sponsor and client can be done by the same person. And it is not necessary that this client has to be sophisticated mathematically, which means it is not necessary that he should be good in mathematics or statistics, but he will be familiar with the relevant business processes and he will serve as the domain expert on the team. Suppose if we take a loan application problem, right? Loan application problem, we have to help the loan officers to score the applications in such a way that he is the one who supports the applicants to apply for the loan, right? So in such a way that we should not provide the loan who cannot repay back, right? So in this application example, so the client may be a loan officer. So we can say he is the one who helps the applicants to apply for loans. And then next one is data scientist. So he is the responsible to take all the necessary steps to make the project to be succeed. And he will set the project strategy and he is the one who keeps the client always informed. And he's the one who designs project steps. He is the one who picks the data sources and he is the one who decides the tools to be used. More technically, he looks at the data and he performs the statistical tests and procedures. He also applies machine learning models and evaluates results. And the next role is data scientist. Sorry, data architect. So he is the one who is responsible to handle the data and he manages the data and the storage. So this role also will be filled by someone outside of the data science group. And the last one is operations. He is the one who manages the infrastructure and finally he deploys the project. And let us move on to the stages of a data science project. So this is the life cycle of the data science project. You see this diagram. So every data science project, it is an iterative process because feedback will be encouraged here and that is reflecting in the life cycle of a data science project. You see here, these are the various stages of data science project. All the data science project will have all of these stages. Okay, 6 stages. First one is defining the goal. Second one, collect and manage goal. And third one, build the model, then evaluate and critique model, then present results and document. And the last one is deploy model. And you see here the arrow. Actually, first you see you will be defining the goal. I'll explain you how to define the goal and what data has to be collected and managed and all these stages separately. But now you look at this life cycle diagram. Here first you see the goal has to be defined. And after defining the goal, we will move on to, we will be collecting the data and somehow we have to manage the data. See here, the arrow. First, we have to define the goal and then we will be moving to the collecting and managing the data. And again, you see the arrow is coming back to defining the goal, right? Because you see, it always encourages the feedback and it is an iterative process. So it is not like waterfall model and one after completing right stages, the system will be developed and not like that. Based on the feedback, we can go back. And again, we can redefine the goal if you're not satisfied. Then only because finally your system has to do the predictions correctly, right? Suppose you have collected the data and you have managed the data. Okay, you have completed that particular task, and then you have built the model. After building the model, you have seen like something is lagging in the collecting and managing the data. Means again you can go back and you can do. So it always encourages the feedback and iteration between the data scientist and all the other stakeholders. So that only is reflecting in this life cycle of the data science project. That's what, even after completing a project, you have deployed a model, and then you have identified some issues, right? That leads to the follow-up project. That is the main thing in the life cycle of a data science project. That's what it is given, loops within loops. And next, so first one is defining a goal. When you're defining a goal, you just focus on, you have to define a measurable and a quantifiable goal. So again, I'll be explaining this with a loan application problem. So the ultimate goal of the loan application problem is you have to develop a system such that it has to reduce the bank's losses due to bad loans. Okay? Here, bad loans are nothing but the loans that cannot be paid, that is defaulted loan. So here the project sponsor, he want to help the loan officer to score the loan applicants so that he can reduce the number of bad loans made. At the same time, it is also important the loan officers, they have to feel the final discretion on loan approvals. So once you, the project sponsor and the other stakeholders, they have to establish some preliminary answers to these questions. And then you have to start defining the precise goal of the project. And this thing you have to keep in mind, like when you're defining goal, it should be specific and measurable. So if your goal is less specific, what will happen? Of course, you will not be knowing what actually you want to achieve, or you will not be knowing when to stop. Definitely, it will lead to the write a bad system. And the second one is, so here in defining the goal, you have to define a measurable and the quantifiable goal, right? So it should be more specific. And then next one is data collection and management. So data collection and management, you have to identify the data and you need to explore the data. And then you have to condition, right? You have to conditioning it to be suitable for analysis. Exploring the data, mostly you can use statistical methods in exploring the data. So you can use R programming and Python. Both are open source. We all know that both are open source data analysis language. But R is best for statistical analysis, and Python is better suited for machine learning algorithms. So any business or industry that collect or utilizes data can benefit from data exploration. Okay, few industries are software development, healthcare, and education. Right. So we need to explore the data by using any of these tools like R programming and Python. And if you're R programming will be better for statistical analysis, and if you're using machine learning algorithms, Python will be right good. And then the advanced visualization techniques employed by data exploration and business intelligence tools enable the business and the stakeholders to better understand performance metrics by making the raw data more comprehensive and creating a story around it. So yes, and we need to conditioning it. You see this example, right? So this is the attributes. Suppose you assume like you have collected a sample of representative loan from the last decade. These are the attributes. You have collected some data. It is a loan application. For a loan application problem, you have collected this data, and when you write there, you assume like you have seen like some of the loans have defaulted. Defaulted means not paid. Okay, those loans are considered as bad loans, and most of them, above 70%, okay, or paid one, right, repaid, which means it will be considered as a good loan. So for this, you have collected a variety of these attributes about each of these applications. Here, good loan represents paid off, and a bad loan represents defaulted. This is the information about information of one sample from a collected data. And here, what you need to do is, I'm telling this for data exploration, right? And as much as possible, you have to try to use information that can be directly measured, okay, rather than information that is inferred from any other measurement. For example, you can take, you may think like you can use the income as a variable, right? Income is a variable. One variable is there. You have all these attributes like a status of existing checking account, it is at the time of time of application, then duration in month, tenor, and then credit history purposes, all this, okay, all these variables. You may think like income alone is enough. All right, income variable alone is enough. Why? Because lower the income, if anybody is having lower income means they will feel difficult to pay off the loan, right? But it is not like that. Okay, here instead of income, you can go with the installment rate in percentage of disposable income. All right, so this information will be more useful than income. Right, so this is the stage where you have to conduct initial exploration and visualization of the data. So for this reason, you should know you have to explore the data. In R programming, you can explore. Even in Python also you can use. And then third one is modeling. So modeling, get into the statistic and machine learning during the modeling, which means here you will be extracting the data very deeply. Like here you will be extracting the useful insights from the data to achieve your goals. So goals are nothing but whatever you have defined previously, right? And in data exploration, you will be exploring the data, right? You can explore the data in many ways, like statistical, you can explore, or by using graphs you can explore. And here you will be you have to extract useful insights from the data to achieve the goal. So since many modeling procedures make specific assumptions about data distribution and relationship, there will be overlap and back and forth between the modeling stage and the data cleaning stage. That is the previous stage. Okay. In the second stage only, you will be collecting the data, you will be managing the data. Managing the data, if your data is not in the ready to go format, means you will be cleaning it. So these are the most common data science modeling tasks we need to perform. First one is classification. So classification will decide if something belongs to one category or another. Right? For this classification algorithms we will be using. And then scoring. So scoring is nothing but when you want to predict or estimate a numeric value, such as the price or probability. Suppose you are having a data set that contains some old core information, and we will be working with the labeled data, right? Labeled data. Suppose if you want to know the old core price and all, you can go for this. Okay, scoring. And then ranking is learning to order items by preferences, right? Based on the priority, ordering the items. And next one is clustering. So clustering is nothing but, the grouping items into most similar groups. And that's to finding relations and categorization. So for the loan application problem, it is a classification problem, right? One example I'll say you, it is a classification problem because you have to identify the loan applicants who are likely to be default. Default means the loan that cannot be paid, right? And here you can use three common approaches like logistic regression or naive-based classifier and decision trees. For this kind of problem, you have to do classification, right? You have to do classification for this loan application problem because you have to classify it, right? Whether it comes under default or not default. So you can go with logistic regression or naive-based classifier and decision trees. And next, this is some only 2 points about R programming. We know that it is the most popular platform for data analysis, and it is a free, it is an open source one, which means it is available for all these kind of operating system like Windows, Mac OS X and Linux operating system. And this R is a complete software package, okay, that will be suitable for data analysis. So statistical analysis, if you are performing this, you can use this R programming. And this is the installation guide for R. And if you want to use our commands and all, you have to install R and R Studio. Or you can install from HTTPS, okay, by using this URL you can install, and for different operating system it is available. So download or for Linux, download or for, okay, so for based on your specification you can download. And then you have to install R Studio. After installing R and R Studio, you have to check that whether R and R Studio is working. For that, you do one thing. You just open it And you can give some commands. You can type some commands in the interactive shell. Okay, one interactive cell will be there. That interactive cell, you can type some commands like 4 plus 5, or you can store some value on a variable, and you have to verify it whether it is working properly or not. Then let us see how can you work with data from files in our program. So the most common ready-to-go format will be in a family of tabular formats called structured values. So almost all the public data, whatever we will be having, will be in the format of tabular, which means it will be represented using rows and columns. So when you read such files into R, you can analyze data from incredible range of public and private data sources. So here I will be explaining you how can you load such a structured files in our program. Because before performing any kind of analysis, right, any kind of analysis, it is important to load the data whatever we are having in your hand in R, right? Then we will be doing the remaining things like exploring and etc. etc. Right. So the easiest data format what we have in our hand will be the table structured data with headers. Right. It will be having the headers, and look at this data. It is a well structured data. So this data directly we can load from your system or from the URL. Suppose you are having your data in your computer system, or it is there in the URL, right? It is there in the URL. You can load in R, even from URL and even from your computer, from the file, right? So the here you see this data. It is arranged in rows and columns. It is arranged in rows and columns. Here, first row gives the column name. This buying, main, those persons. Okay, all these are column names, and each column represents different fact. Okay, each of this column, buying B high, B high, B high, B high. This is the fact. This is the information about that buying. Then it gives the fact or measurement about that column. And each row represents an instance or the datum about which we know the set of facts. So a lot of public data will be in the format, will be in this tabular format only. And here you see this header row contains the name of the data format, right? So here it is separated by comma. Hence it is called as comma separated value. You know, easily comma separated values you can load and you can do analysis kind of thing. And then here you see this VI, this is nothing but instance about, right? Instance, this is the core data, okay? This is the core data. And here the data rows, okay, all these data rows are in the form of header row, right? But each row contains actual data values. These are the data values. And here the first row represents, you see, the set of main value pairs, like buying is equal to, take this first row. So buying is V high, and maintenance is D high, and those are 2. So this is about the information of this particular model 1 core, right? Buying very high, and maintenance very high it seems, and doors 2 it seems, and 2 persons right? That is the meaning of this. 2 persons then small, it looks small it seems, right? That is the information about that particular core. And another core, it is V high, 2 small, medium, and so let us see how can you load this. This is the OR command to load data from files or URLs, right? We have to use this OR command read.table of, right? Read.table of, and we are done. If data were always in this format means we can go with if it is in the structured, well-structured format. This is the labeled data that. If it is in the well-structured format means again you can go for the modeling. And then, right, here you see what happened, read.table of. So this command, this loads the data and it stores a new our data frame object called UCI core. So now we have created a data frame. Our data frame object, it is nothing but UCA core, and these data frames are nothing but it represents the data in rows and column format only, right? And this reader table of command is it is a powerful and the flexible one. It can accept many different types of data separators. Okay, here for in our example, our data is of CSV form, right? CSV comma separated form. Whereas this reader table of accepts tags separated, then spaces, pipes, and others. And it also have many options for controlling, quoting, and escaping data. This also reads files from local files and remote URLs. That's what I told you. If a resource name sends with the .gz suffix, suppose you see if you want to load the compressed data, even compressed data also you can load. This read dot table of is flexible for that. So when you are loading the compressed data, it automatically decompresses it while reading. Right, reader table of will automatically decompress it while reading. And you see this, you need to specify this URL. Okay, actually this is the command directly. The data set is used from the URL. That's why you see it comes in single quotes, and then you have to specify what separator, right? Comma means comma, and tab means space, like that. And header is equal to TRF comes. If first row represents header, means you have to specify it as T. Header is equal to T. Right, now you see, assume like we have loaded the data, right? Either from the local file or from URL. And after this, we need to examine our data, right? You have to examine our data. So we can examine our data by using all these commands like class of. So this class of will tell you what type of or object you have. For this case, if we use class of UCA core, it will print like data type frame, and you will be knowing like it is represented, it is a data of tabular format, right? And then, so here you have to use class of UCA core and then help of, right? So this help of command will give you the documentation for a class. And then another one is summary of, this is very important command to explore the data. So summary of will give you summary of almost any OR object. So suppose if you use summary of UCA car, it show you a lot about the distribution of the UCA core data. And then you see one more important command is dim off. Okay, it shows you the dimension like how many rows and columns are there in the data. You can see here. You see this. So class of UCA core is used. Summary of UCA core. So this is showing a distribution of all the variables, right? Buying is one attribute, right? One attribute. Here it is showing like how many buying with high values, 432, low values, mid, B high. So it is giving you the distribution about the variables of the data set, okay? Variables of attributes of the data set and maintenance dose, etc. So this here you see each core in the data set was declared. If you see the person 2, so here you can see that 576 two-seater cars are there in the data set. You see this person's 2. So here 576 it is, and 576 4, which means 576 two-seater cars are there in the data sets. Like that, we can explore the data. We can examine the data. And it's working with other data formats. I told you that reader table of you can use to load CSV tabs and separated. Even if you want to load, other data files format also you can load, which includes XLS. For that and all, we are having corresponding packages. And next step. So previously we have seen if you want to work with the, right, if you want to use well-structured data, just you need to load it and then you can go for model. And if it is not a well-structured like this, right, what you have to do. So we will be knowing that data isn't always available in a ready to go format. Okay, like previously. So instead of reformatting the data, you can transform the data into some meaningful, okay, using or. You see this data, we will be seeing like there is no header in this data, right? This is the German bank credit card. So whatever data set I am explaining here, or the data set that is available in UCI machine learning repository. This is German bank credit card. So this data is stored as tabular data, but it does not have a header. So in this case, what you need to do is, instead of reformatting the data before we bring into it, or what you do is you can transform the data into some meaningful using or. Okay, so let us see how can you transform this kind of less structured data. Right. So I will explain you what is this data. See, here, this is the data set. It contains 20 input columns, right? It contains all the data is not shown here, but it contains 20 input columns followed by one result column, right? And you can see that there is no header in the data file. And the column definition and the meaning of it, actually this A11, A12, A14, it is having a specific meaning, but that is not available here. So what you need to do is you have to include. Then only you can, you have to make it to be sensible, right? It should be a meaningful. So this A11, A12 are nothing but cryptic A codes. And the detail about the information will be there in the documentation. If a data is there, means documentation will be there. There you can see the meaning of this data, right? So let us see how can you load this kind of raw data into OR, right? So first what you need to do is you just have to load like this by using read.table of, okay, either from the local file or from the URL. And then you have to set the column names, right? Then it becomes meaningful. So these are the column names. Right. Here you see one command we are using, that is cof. The cof command in our method, it is used to construct a vector. So if you want to construct a vector, means you have to use the command cof. So here what we have done is directly we have copied the column names from the dataset documentation. Right. You may get a doubt like of how we know that the status of existing checking account level, it is taken from the documentation. Right, then what you need to do is we have assigned this, right? So then you need to assign this vector of names into the data frames columns of slot. So columns of B, C. So this is an assignment operator in OR. This is an alternative of assignment operator equal to, right? And what we have done, we have copied all this. Okay, this one is taken from the documentation. We have copied all these names from the dataset documentation, and it is assigned to the data frame column names of B. And now what you need to do is we have to reset the data frames column names to something sensible, which means you need to map it, right? So A40 means core new, A41 means core used, A42 means furniture or equipment. So for this, what you need to do is you have to use this. For I is equal to 1:n, we are assigning this to all these cryptic code. And next, after mapping, you can examine the data by using the previous commands, right? Summary of you can use. Otherwise, this table of the purpose good adult loan. So this is showing bad loans, good loans, those who are having right purpose is business. Then core they would have used for they would have taken the loan to buy a new car or used cars. Out of that, how many are bad loan, which means how many loans are not paid and how many loans are paid, which means you see somebody has taken a loan for some business purpose, it seems, and out of that 34% of the people are not paid, it seems, and 63 are not. 63 are paid, and some people, right, they have taken to buy a new car, out of that 89 is paid and 145. Like this, you see, you can explore the data. You can examine the data. And then, okay, let us see the brief on exploring the data. So you can explore the data by using two ways. One is statistics and another one is visualization. So statistics. Using statistics, what you can do is you can spot the problems. You can identify the problems that is there in your data, right? So for this, we will be using the command summary of. So this is the customer data, another data set. It is nothing but the customer data. So it contains the information about the customer. And when you use summary of customer, you see, we can see all these things, mean, median, third quartile, then maximum value, minimum value, etc. Right. So the summary command on a data frame, it will give you a variety of summary statistics on the numerical columns of the data frame. And it also counts on any categorical columns. So categorical variables, you know that what is a categorical variable, right? So categorical variables are nothing but the data which can be divided into groups. So examples of categorical variables are race, age group, educational level, etc. Right? So see this data. So this one we got by using summary of. Here you see is employed, income, then divorced, separated. So how many are married, how many are not married, then how many are widowed, how many of these people are having insurance, right? Health insurance, 159, 841 are having, it seems, and 159 are not having, it seems. Okay, this is the data about, this is the description about the variables of the particular data set customer. And then missing values. Here you see many problems you can identify, right? Many problems, like first one is you can identify missing values, right? Here you see this data set is employed, is not employed income, right? It is showing like non-appear, NA means the data is not available, right? So that particular field is, there is no data in that particular field. So like this, 328 fields data are not available, right? So these data is nothing but missing data. Suppose if any of the data are, if any of the numerical values are missed, means what you need to do is you have to repair. Right? So a few missing values may not be really be a problem. Some of the missing values may not be a problem. So what you can do is, if it is not a problem, means what you can do is you just completely drop that particular row. Right? You can completely drop that particular row. But if you feel like those missing values or those attributes are meaningful, it is important for your work. Okay, it is important means what you need to do is you have to do some other options. If it is not, if it is not useful means okay, you can drop it. But if it will be useful means some other ways only we have to use to fill that data. Then only it will become sensible. Right. So you have to decide whether you have to drop all the rows where the field is missing, or you have to convert the missing value to 0 or any other additional category. That you only have to decide. And next one is you also can identify while exploring the data using statistics, right? Using statistics, that is using summary of, you can find all these issues, right? Sometimes some of the values may not be appear. If it is not appearing means either you drop it or you have to fill that particular field with zeros, right? And suppose if we find any invalid values, see here, in this income, right? So this is about income data, right? This is income, and here you see the minimum value is minus 8,700. So people write income, how it comes minus, right? It is like a penalty or something. It is not a meaningful, right? If you identify such invalid values, right? What you need to do is you have to make it to be sensible. Right? So such values also you need to explore, right? You can explore. by using summary. Summary of only I have used here, and you see I have identified like some minimum value. And even if you see age also minimum value is 0, but you can see the maximum value is something like 147, 148, and who is living up to 147 and all, right? So of course it is not a valid value, right? It is lying something outlier out of the out. It is lying something outside the range. So what you need to do is you have to fix it. And next is data range. So if you also have to pay attention to see how much the values in the data vary. For this income is taken, that's what it is coming in minus, right? So it is lying out of the range. These things you can explore. And next one is spotting problems using graphics and visualization. I told you that data exploration you can do in 2 ways. One is statistically you can do, and another one is you also can identify all those problems like outliers, then invalid values and all. And you can see the relationship between dependent variable, not dependent variable, and dependent variable, and by using graphs also. So visualization is nothing but graphing the data, right? Graphing the data is the visualization. For visualization, we will be using ggplot, right? ggplot2 in order to demonstrate the visualization and graphics. We have chosen ggplot2 because it combines multiple graphical elements together. And ggplotter function declares the graph object. Right, this kind of graphs and all you can draw by using ggplot2 in our program. Here in ggplot2, the arguments to ggplot2, you have to give the arguments like data frame. So data frame of interest, that is nothing but your data, and the aesthetics. And this ggplotter function does not itself produce any visualization. So it will be produced by layers. So these layers produce the plots, and plots transformations are added to a given graph object by using plus operator. Here you can see. Just a minute. I told you that by using ggplot2 only, you can visualize your data. Right? You can visualize your data to identifying the problems only. Right? We will be exploring more about the data. You see this, first you need to install this package ggplot2. Okay, for installing you have to use library of ggplot. It will be available in all. And then ggplot of customer data. So I told you that ggplot of function contains 2 parameters. Okay, one is you have to give the data, and that should be an OR object of data frame type, or object of data frame type. And then you have to specify it. You see geom underscore histogram of, here you see histogram is drawn, it seems. Then it contains AES of function. So this AES of function contains X and Y values. Here by using this you can represent X and Y variables. Also many other parameters. Okay, for histogram bin width and all you need to specify. Okay. And then while visualizing the data, that is using while examining the data using visualization, you have to keep all these things in your mind. Like you have to avoid too many superimposed elements, which means you have to avoid too many curves in the same graphing space. If you're having too many curves, definitely you cannot explore the data, right? Some of the values, if you want to identify, means you cannot see it. And then you have to find the right aspect ratio and scaling to properly bring out the details of the data. Then you have to avoid having the data all skewed to one side or the other of your graph. So skewing means many data points may lie in one side, right? I'll show you the example. Right, here you see some of the data points are lied. Many of the data points are lied here, and here exactly you cannot explore the data, right? So you should not draw the graph like this. So your visualization will help you to answer the questions like what will be the peak value of the distribution, Right here in this graph, you can see this is the density plot. Here you can see that the peak value of the distribution, and then how many peaks are there in the distribution, and then how normal the data is, and how the data is varying. All these things you can see by using visualization. And first one is histogram. So here you see the histogram and the density plots are two visualization that will be helpful to examine the distribution of a numerical variable. Right? Suppose you see if you want to return the number of data points that falls into each bucket, right? Again, you come to the customer data. Assume like you could group the customers by age range, okay? Intervals from 20 to 25, then 25 to 30 and 30 to 35 and so on. You want to see how many people are there within the age group 20 to 25 and 25 to 30 for some kind of analysis, right? In such cases, you can go for this histogram, right? Here, each bucket represents how many customers are there in the each bucket represents the interval, okay, 20 to 25, 25 to 30. That and all based on your need, you can decide. And this is the graph, histogram. You can create the histogram by using this ggplotter function. Here you have to use geom_histogram. And aesthetic specify all x variables, y variables, and it also contains some other parameters like bin width also you can specify. And then fill like what color the bucket has to be filled. It also contains so many, that is an optional one, but x variable you have to specify here. So your x will be the age, right? X is the age and y is the frequency, number of people those who fall under that particular age group, okay, 20 to 25, 30 to 35, etc. And next one is density plots. Okay, suppose if your data is very wide, right? So density plot, you also can say this density plot as the continuous histogram of a variable, right? And if the data range is very wide and the Morse distribution is heavily concentrated to one side, means you can go with this density plots. For drawing, for visualizing the density plot, you have to call the function geom_density, and all the x and y variables and the other parameters has to be used. This is the code for any count, right? And if the data is non-negative means, then you can, because when you see here in density plot, this is a plotter, this is the density. Here exactly you cannot see. Suppose if you want to see the value here, right, at the data point here, exactly you cannot count it. Okay? For in such cases, what you can do is you can go with the logarithmic scale. Right, you can go with logarithmic scale. So exactly you can see what is there in that particular data point. And next one is bar chart. Bar chart. So this bar chart is a histogram for discrete data. It records the frequency of every value of a categorical value. So here you see, you can see how many divorced people or separated people is there, how many are married, how many are never married, how many are widowed. These things you can explore by using bar charts. And then horizontal bar chart also you can develop. And this is the command for developing the bar chart, geom_bar, this function here in our program. And then if you want to produce a horizontal bar chart, you also can produce the horizontal bar chart like this. Right. And then suppose if you want to see the relationship between the two variables, that is histogram bar chart and the frequency count. Right? How many number of people are coming under, how many data points are coming under that particular age group or that particular, right? There you can go for even categorical data also you can plot using bar chart. And then if you want to see when you want to see the relationship between the two variables, you can see the relationship between the two variables by using different visualization tools. First one is line plot. So here this line plot will work based on the relationship between the two variables. So X variable has a unique Y variable. So here you can see it is the relationship between the dependent and the independent variable. Right? It shows how the value of Y is varying with X value. Next term is scatter plots and smoothing curves. So scatter plot also, of course, it shows the relationship between two variables, right? Age and income. So if you want to explore age and income, right? How income, whether income is rising when the person becoming old. When the age grows, automatically we may have a thought like income also grows. If you want to see, if you want to explore how income is rising or how income is moving with your age, you can go for this kind of plot like scatter plot and smoothing curves. Right. Scatter plot with a smoothing curve makes a better visualization, which shows the better relationship between a continuous variable and a Boolean. So here you can see, you see this graph. When the income is growing, when the person with the age 60 and 80, their income is reducing, right? This graph is telling like that. And exactly, if you want to see the exact meaning of this data set, smoothing curve you have to draw. So this shows the relationship between a continuous variable and a Boolean. That's it. When you want to see the relationship between the age and the income, it is not an easy one. So you can try to make the relationship clear by plotting linear filter also. And then Hesbin plots. Right. So now let us go back to the income versus age example. Here, this figure shows a Hesbin plot of the data. Note how the smoothing curve traces of the shape formed by the densest region of data. To make a Hesbin plot in DRA, you have to install the Hesbin package. Okay, Hesbin package has to be installed to draw this Hesbin. Right? So this is like a two-dimensional histogram. And here the data will be divided into bins and the number of data points in each bin will be represented by color of shade. And then even you also can visualize categorical variables by using bar chart. Categorical variables, if you want to visualize, that also you can visualize by using bar chart. And this is the most straightforward way. This shows the relationship between marital status and the probability of health insurance coverage. And this is a stacked bar chart. Okay? This bar chart is called a stacked bar chart. Here you see, you can see how many divorced person or married person are having health insurance and how many are not having health insurance. Right? So here this false and true is nothing but false means how many are not having and true means how many are having health insurance. And how it is represented, you see this diagram. So divorcee or separated, how many, right, count you can see how many divorcees are having health insurance and not having health insurance. How many married people are having insurance and don't have insurance. So here we are visualizing the relationship and the probability of the health insurance by using the stacked bar chart. So some of the people, they also will prefer the side-by-side bar chart. We can do that. Right, many different types of bar charts are there. I'll be skipping this. And next one is managing the data. Right. Suppose you see you have identified, like I told you that when you are exploring the data, you may have identified like some of the data are missed and but it may be unuseful and all. So how can you fill the data? Right? How can you make that missing values to be a meaningful value? That only we are going to see here. So treating a missing values. Here in R, NA means not available data. Right? If the data is not available, it means we will represent it as NA. So here there are two things you can do with these variables. Either you can drop the row with the missing values or you can convert the missing values to a meaningful value. right? If you feel like that particular attribute, okay, is not that much important, you can ignore the particular row with the missing values. You see this here for housing dot type reason dot move not appear is 56. So 56 is less number of fields only, right? Not available. In this case, what you can do is you can drop the rows, right? Because 56 rows only are having missing values, so you can drop this. But whereas you see is employed not appear data is 328. So 328 data fields are missing. So in such cases, it is not a meaningful, right? Which means you have to fill this with some other data. So missing data in categorical variable. Suppose if the categorical variables are missed, means that is you're having a data like is employed or not employed, you want to see whether the person, right, customer is employed or not employed, if you want to see means. And if you found like some of the fields are not appear means, and if you feel like that too it is a very meaningful information and you cannot delete the rows, right? In such cases, you cannot drop the rows. In such cases, what you need to do is you have to make it as a categorical variable. So you can say how many, you can create a categorical variable named missing and you can represent it. Here you see this. So employed 599 employed and missing is 328 and not employed is 73. By using this command, you can, for not appearing, we have included a categorical variable missing and then we are assigning that value to this missing. So this 328 will be considered as missing value, right? And here we have used the categorical. One category we have, variable we have included, right? That is one way. And then if the missing value is a numeric data, suppose income variable, some right income variable, you see many of them appear like 328 for 328 data and all, you cannot ignore that row, right? In such cases, what you can do is you can fill the value with the expected or the, right? For an income variable, if found that not appear 328 cases are there, right? What you need to do is you cannot, definitely you cannot drop that row. So in such cases, you have to fill that missing value with the expected or mean income by using this command. Next one, when the values are missing systematically, another way is you can convert the numerical data into categorical data, and then you can use the methods that we discussed previously, right? Some of the numeric data, like numerical data are missed means what you can do is you can fill it with the categorical data. Like you can assign the categorical variable and some of the methods that we have discussed previously, like you can, right, you can assign a categorical variable and you can do it. Right. And next one is data transformation. So that is about cleaning the data and then data transformation. So data also has to be transformed. So how can you convert the continuous variables to the discrete variables? You need to, sometimes you may require to convert the continuous variables to the discrete variables. And next one is normalization and rescaling. So this normalization will be useful when absolute quantities are less meaningful than relative ones. And the rescaling means you can use the standard deviation as a unit of distance. Here you see standard deviation is used to rescale the. And next, log transformations. So all these transformations you can do for skewed and wide distribution. Sometimes what will happen, large data points will fall on one side. In such cases, exploring the data will be very difficult. So what you have to do is you have to convert it into log transformations, right? So it is a very good idea to make the log transform data with values that range over several orders of magnitude. That's what, if your data is skewed in one end, you can go with logarithm transformation. And there are some other transforms also are there, but it won't be meaningful. And then sampling. Sampling, how can you do in or? Listen, you can do, sampling is very important, right? For modeling and validation, sampling has to be done, which means you need to split your data for testing and training. In odd programming, testing and to split your data, right? You have to use GP. You see this code, you see this command. So customer data, we are splitting. So here you see run if of dim customer data of 1 means it returns the number of rows. This returns the number of rows. Here we are taking 10% of the data for the testing. All right, by using directly, you can use GP to do the random sample of the data. Right, GP is used here. You see this test set, a subset of cust data, comma, customer data, GP less than or equal to 0.1, which means 10% of the data is sampled for testing. Right, is taken for testing, and the remaining greater than 0.1, which means remaining 90% are taken for training. Then some of the modeling methods we can see. Some of the modeling methods we can see. One is classification. So classification, we know that it is the process of predicting the class of given data points. So classes are called as classes are sometimes called as targets or labels or categories, and classification belongs to the category of supervised learning. So classification here we will be training the algorithm by using labeled data. Right, so classification comes under supervised learning. For this, for classification, we can use classification algorithms like linear regression, then logistic regression, the naive Bayes, and support vector mission. I will explain you linear regression. So this is one of the easiest and the most popular machine learning algorithm. This machine learning algorithm will be used for predictive analysis. Already I told that predictive analysis means if you want to see an election and all, or this will give you the numerical result, right? So this shows a linear relationship between a dependent and a more independent variable. Hence it is called a linear regression. Suppose you see you have a data set x and y, and x is a dependent variable and y is an independent variable, right? X is a dependent variable. Dependent variable, the value of the dependent variable depends with some value of the independent variable. Suppose like this, you are having a data like this, right? This is the solved example. So here you see it contains xi and yi. Xi is nothing but scores on the aptitude test. Right, 5 samples are taken from the data set, and we are going to find the student score if the student's aptitude mark is 90. By using linear regression, we can solve this. Right, so xi represents aptitude, marks of aptitude, and yi represents student score. So here we have 5 students' marks. Okay, one student has taken 85, if he has taken 95 aptitude and his final score is 85, it seems. And another student has taken 85 and 95. And what you need to do is you have to see, you have to find the student's aptitude mark is 90 means what will be the what will be the final that you need to find. Right, so that is this classification, that is this linear regression. Right, this linear regression shows the relationship between the independent and the dependent variable. So here what you have to do is we can see that when the value of you see x increases, the dependent value of yi increases or decreases in somehow. So what you have to do is mathematically you need to represent, right? That is called as we can represent by using line, okay, linear regression. So it will be the value of y independent dependent variable may be increased, the value of x increases or decreases. So again here negative regression comes, okay, and positive regression line comes. So what you need to do is you have to find the best linear regression. Right, here you see what it is calculated, xi minus x and yi minus y is calculated, and the mean of x and y is taken. And then xi minus x the whole square and yi minus y the whole square is computed. And then you see here this b1 is nothing but x coefficient. Okay, that is a regression coefficient. What you need to do is we will be using the linear regression equation y is equal to b naught plus b1 x, because y is an independent, y is a dependent one, right? So the value of y depends to the independent variable x, right? So here to find the regression coefficient, it is calculated by using this formula. So you will get a b1 is equal to 0.644, and then intercept you need to compute, right? Intercept you have to find, and you will get a b naught is equal to 26.768, and this will be applied for 90, right? Once you got the values b naught, and that is once you identified the coefficient and the intercept, of course you can apply the values and you will find it, and we have got 84.728. So this linear regression problem, okay, it comes under scoring problems. This linear regression algorithm you can implement in R very easily. Okay, I will show you the code for this. Yes, linear regression. Right, since we are taking, otherwise what you need to do is, if you are taking a data set, right, we will be having, we will be taking more samples, right? It will be contain more samples. So in such cases, you have to load the data, and then you have to use this function lm of, right, y is the dependent one, and x is an independent variable. This is not value of height. This is aptitude score, and this is the final score of the student, right? Here x is an independent variable and y is a dependent variable. We have applied linear regression here, right? It is lm of function. So lm of y tilde x shows the, I will execute this, you will get the same answer. So this shows the student score. If the student's aptitude score is 90. Okay, I'm running this. You see, it is printed like 84.72603. So almost even naive-based classification also you can implement in our programming. So statistical analysis, even modeling also you can do by using our programming. Here I will explain. You see, so data frame x equal to 90 is your input. Okay, here input you have to give x equal to 90, and then we are predicting, right? LM of y tilde x is very important here. Right? Only by using LM of function, linear regression, so that is scoring problem we have solved. And then naive-based classification. Naive-based classification, even naive-based classification, naive-based algorithm is also supervised learning algorithm. Here also algorithm will be trained using labeled data, but it works based on Bayes' theorem. Classification problem you can solve by using naive-based classification algorithm. It will be useful in all these things like sentimental analysis, classifying articles, and all. So this works based on this Bayes' theorem. It is a conditional probability P of A by B equal to P of B by A into P of A by P of B. So here, suppose you see you got a data, you have given a data like this, and you have to identify like if it is sunny today, whether they can able to play, right? You need to identify, and from the data you need to classify it, okay? Whether they can play or not, right? When it is sunny. So this particular data set contains 14 samples. So for this, first what you need to do is you have to right. You have to first you have to generate the frequency table. right? You have to generate the frequency table for all these labels, okay? Overcast, rainy, sunny. For all these variables, you have to generate the frequency table. So here you will be having 5s, it seems. 5 times when it is sunny, it is when it is overcast, it is overcast means cloudy. The weather is something cloudy means how many times they have played. So S is 5 and not played is 0. And when it is rainy, 2 times played it seems and 2 times not played. When it is sunny, 3 times played and 2 times not played. So total how many times played and how many times not played, whatever may be the climate. So this is your frequency variable. And then this is the likelihood table. So again, you have to generate the likelihood table also. And from this, you see, you need to apply the Bayes theorem. So Bayes theorem is posterior probability, right? When whether it is to be played when it is sunny, right? So sunny by yes, okay, you will be knowing. You will be knowing from the likelihood table. So how many times when it is sunny they have played, but here it is a posterior, and the final result will be the one with the probability higher. Here you see P of S, P of S we will be getting 0.71 and S by sunny, and P of no by sunny is lesser than that, right? 0.35 it seems. So the probability, highest probability is highest value where we got yes, you can play it seems when it is sunny. So 71 percentage, right? 71 percentage, and this is no is 41 percentage. So you have to prefer yes. So if it is sunny, you can like this. You can classify. So this naive-Bayes classification also supervised. With this, I'll close this session. So,
Any participants, if you're having any queries, you can ask questions, ma'am. Okay, ma'am. Thank you. I think we can wind up the session now.
yes, thank you, sir.
Thank you very much for your wonderful session, madam, regarding data science using R. Thank you. Thank you very much. And thank you for the participants also those are patiently listening to the session throughout the time. Thank you all. And participants, I will share the feedback link in the chat window as well as our WhatsApp group also. Kindly fill the feedback form. Thank you all.